bus leaves Rakiraki at 8:30 a.m. That's the start time for the journey. We have here the travel time of 3 hours, and we want to know the end time. The thing you can do is just add these columns straight down as if it were addition. So 0 plus 0, 0. 3 plus 0 is 3. 8 plus 3 is 11. Now this, and of course it's still AM. If you add this column and it comes to 59, then you write it down as 59. The minute it reaches 60, you write 0, 0, and you carry 1 over, because there are only 60 minutes in 1 hour. Carry over to become 1 hour. And these numbers, if you're working on the 12-hour clock, so 1 a.m. through to 12 p.m. and then start again 1 p.m., 2 p.m., 3 p.m. and so forth, then you're working on 12 hours, and this only hits 12 before it returns to 1. So in this case you don't have that problem, because 8 plus 3 is 11. You haven't reached 12 yet, so you don't have a problem. That's exactly how you write it down. And here you only reach 30, you don't reach 60, so that's exactly how you write it down. And it's still AM. If for example you're using the 12-hour clock and this number reaches 12, as soon as it reaches 12, that AM changes to PM. So you can have 11:59 as soon as it reaches 12.00, then that is from AM it's switched to PM, or if it was PM before, it switches to AM. Okay, so that is the answer. That is the time that the bus arrives in Suva. For this particular problem, we're told that Mr. Karan earns $12.50 a day, and we asked how much will he earn if he works for 6 days. So we want the $12.50 on the first day, $12.50 on the second day, $12.50 on the third day, all up to the 6th day. So what you're doing is really $12.50 times 6. Okay. If you've watched the videos I've done on decimals, you'll know that the decimal point is very important. But for multiplication, there's a shortcut. After you multiply everything out, then you count how many places to the right of the decimal point in both of the factors, in this number and this number. And then that's what you will do to the answer. Make sure you have the same number of numbers to the right of the decimal point. So we'll start. 6 times 0, 0. 6 5s are 30, 0. Carry 3. 6 2s are 12, 13, 14, 15. Carry 1. 1 times 6, 6 plus 1 is 7. Okay. Now, like I said at the beginning, count how many places after the decimal place. Here, 1, 2, and on this one, 0. So you've got 2, and so you put the decimal place right there. So you can also have in the answer 2 numbers after the decimal point. And you're giving your answer in dollars, because it says how much would he earn? How much would he earn? So you're talking about dollars, you give your answer in dollars, and that's the answer, $75. Here you are told that school starts at 8:30. You don't know how long they're in school, that's the question. You're trying to find out what number of hours has passed in between, what is the number of hours and minutes that you're adding in order to end up at 3 p.m. Now, as I had 2 questions ago, I said to you that AM changes to PM only after this hours here, the hours side, this column here has reached 12. So you know this has gone to 12 and then a further 3 after that. 8 goes to 12 and then a further 3. So 12 plus 3, it would have added up to 15, right? So basically you're trying to find a number here that you add to 8 in order to get to 15. Because it was 12 plus 3, it ended up at 15. These pens are not cooperating, ended up at 15. Okay, 8 plus something ended up at 15. Now here 30 plus something equals 0, 0. Remember, when it hits 60, it goes to 0. It goes to 59, then as soon as it hits 60, this turns to 0 and we carry 1 up. So you know now that this is 30, because 30 plus 30 will give you 60, that will make this 0, right? But when this is 0, you're carrying 1 across. So you know that's 9 plus something equals 15. 9 plus what equals 15? 9 plus 6, right? 9 plus 6 is equal to 15. 6. Okay, let's try and test this. 30 plus 30 is equal to 60, which turns to 0, 0. You carry 1. 1 plus 8 is 9. Plus 6 is 15. Then you get 15, but as soon as you pass 12, you have to minus 12. Because you're starting again at the start, 0, and then you're counting back up. So whatever number you get, you minus 12. 15 minus 12 is equal to 3. So that is the correct answer. 3 p.m. Remember, this column reaches 60 and switches to 0, carry 1. And this column only hits 12 and then it starts again at 0, 1, 2, and so forth. And we knew it had hit 12 because AM changed to PM. If this was still AM, then we wouldn't be sure about it hitting 12. Number 36 gives you coins, pictures of coins. And here what I've done is just expressed in dollar form. This is of course 0.00 here. Just expressed in dollar form this way, all the coins that are shown in the picture. There are two $2 coins. There are two $1 coins. There's one 50-cent coin, two 20-cent coins. So this is how you'd write it, $0.50. The 20-cent coins, it's 0.20. The 10-cent coin, there's one, so I put 0.10. And there are two 5-cent coins, so 0.05. So that's just expressing the coin as a decimal, right? Okay, so I'm going to add up these two separate columns. One is the dollar coins and one are the smaller denomination coins. Let's start with here. 5 plus 5 is 0. 0, carry 1. Here that's 5, 6, 7, 8, 9, 10, 11. So 1 decimal point, carry 1, $1.10 from these smaller coins. And here, this is fairly simple, 0, 0, and 6. And if you add these together, 6 plus 1, 10 is equal to $7.10. 10 cents. So this is where your use of decimals becomes useful in showing you're working out for adding money, coins, because then you can show the cents as the numbers to the left of to the right of the decimal point. So make sure your columns are aligned, your decimal points are all aligned when you're adding, all aligned, to make sure that your answer is more chances of being accurate. So the question is, how exactly is the question phrased? The question says the total value of the coins below is $7.10. When you're talking about value, express it as dollar in dollars, so you must have the dollar sign in front of your answer. Okay, we're given a problem where we are told that the total weight of something, the total weight, that is the weight of the crate and the weight of the bottles together, the total weight is 4 kg. And we're told that the weight of the bottles, not the bottles in the crate, just the bottles by themselves, that it is 2.3 kg. Now, why I've written it like this is so that you can clearly see that crate plus bottle equals total. You're given the total weight of 4 kg. You're given the bottle weight of 2.3 kg. Now you just need to find out what is the crate weight by itself, without the bottles, by itself. Because you know the crate weight plus bottle weight is 4 kg. Now, how do you get a number if you already know the total? What you need to do is you subtract the other addend from the total. So 4.0 minus 2.3 is equal to what? So you're doing subtraction of decimals. Here you will borrow from this side. It will be 10. 10 minus 3 is 7. 3 minus 2, don't minus 4, 2 from 4. This one has become 3, remember. So 3 minus 2 is 1. So you know the answer that you're looking for is 1.7 kg. Let's just test that out. 7 plus 3 is 10, 0 there, carry 1, carry 1 here. 1 plus 1 plus 2 is 4. And there you have it. So this looks like it works out. You can always test your answer by doing some small addition later just to check that everything makes sense and looks to be correct. So the answer is 1.7 kg. The crate weight on its own is 1.7 kg. Okay, this question asks you to convert a time, 2:56 p.m., and express it in terms of the 24-hour clock. Now, if you are not familiar with the 24-hour clock, we've been thinking of time in terms of 12-hour blocks. So one day has 24 hours, but we think of it as split into two separate 12-hour blocks. So we say 1 a.m., 2 a.m., 3 a.m., it goes till 11, 11:59 a.m., and then 12, midday, it switches to p.m. That's midday. And then it goes 1 p.m., 2 p.m., 3 p.m., 4 p.m., 5 p.m., 6 p.m., 7 p.m., all the way to 11 p.m., 11:59 p.m., 1 minute before midnight. And then when it's 12 midnight, it becomes a.m. again. Right? So that's the cycle that we go with when we're working with the 12-hour clock. With the 24-hour clock, we're starting at the same point, and that is at midnight. Whereas in the 12-hour clock, it's 12 a.m. On the 24-hour clock, it's 100 hours. It's 0. So that's the 0 point. And then from there, the number gets bigger and bigger and bigger until it gets to 12:59. You notice that we don't say AM or PM when we're talking about the 12-hour clock. We use AM and PM with the 24-hour clock. When we use the 12-hour clock, we are using AM and PM. AM for the morning, starts at midnight and then comes through to just before midday. And then from noon, 12 p.m., midday is noon. From then on, it becomes PM. 12 hours, the 12-hour clock, 12 is also 12. But after that, instead of returning to 0 and going 1, 2, 3 p.m., it continues. So whereas it's 1 p.m. on the 12-hour clock, it's 1300 hours on the 12-hour clock. Do you notice the relationship between the 1 and the 13? It's plus 12. So the easiest way to convert it is to, once you're talking about any number under 12 in terms of AM, then that is the exact same number, unless you're talking of 12 AM itself, in which case it's 0. But any other number looks to be the same, right? 11, 11, 11:59, 11:59. You just drop off the AM, don't use the AM. When you get to 12, still 12. But after 12, where on the 12-hour clock it goes to PM, you just plus 12 to get the 24-hour time. So here it's 1 p.m. plus 12 is 13. 1 plus 12 is 13. It's 1300 hours. Don't say PM or AM. It's just 1300 hours. 6 plus 12, 1800 hours. 11 plus 12, 2300 hours. 11:59, 1 minute before midnight, is 2300 hours and 59 minutes. So how do we approach this? It is PM, so PM is when you start adding the 12. So don't worry about the minutes because we don't have any minutes to add, we're just adding hours. So we have 2:56, you add 12, 0, 0, and you have 14:56. So this is actually 14:56 on the 24-hour clock. And that's your answer. In number 39, Thomas has $4.60. Let's just check his name again. Yes, Thomas had $4.60 and his sister gave him 75 cents. All the coins, all the money, you express it as decimals when you're doing your working out. So 75 cents, anything under $1, it will appear on this side of the decimal place, of the decimal point, on the right side of the decimal point. It will be a number smaller than 1. As soon as it hits $1, you'll have the 1 showing here in the units column. Or in this case, in the dollars column, since you're dealing with dollars. So 75, all you're doing is adding the 75 cents to the $4.60 that Thomas already has. 75 cents is expressed as this. In dollar terms, it's 0.75. If it were 50 cents, it would be 0.50. If it were 20 cents, it would be 0.20. 95 cents, 0.95. Okay, let's just continue and solve this one. 0 plus 5 is 5. 6 plus 7 is 3. Put the decimal point, make sure it's aligned. Carry 1. 1 and 4 is 5 plus 0,
Still 5. How much would he have altogether? $5.35. Okay, the next question is how many lines of symmetry does a rectangle have, right? Rectangle has how many lines of symmetry? A line of symmetry is a line that just divides a shape down the center, going through the midpoint of the shape, the middle point of the shape. That line goes through so that both sides of the shape are exactly the same, and when you fold them, they line up perfectly. That's perfectly symmetrical, right? So that line that runs through the shape where both sides are the same, that's the line of symmetry. How many does a rectangle have? Okay. Here I have a rectangle. Now just to illustrate, if I fold it along that midway line, you see both sides are perfectly folded onto each other. There's no overlap, right? That's because both sides, this side and this side, is symmetrical along this line of symmetry. So that's one line. What about this line? So this one also goes through the midpoint. If I fold it here, this side and this side, they match exactly. So this side and this side along this line of symmetry running down here, these lines, these sides are also symmetrical, right? So that's a second line of symmetry. So we know for sure it has two. What about if we try diagonal? Because that goes through the middle as well. If I fold it along the diagonal, what happens there? There's overlap. That is because it is not symmetrical. The shapes are similar, but they're not symmetrical. So a rectangle has only two lines of symmetry. They're drawn on this piece of paper, and they're also drawn on the picture of the rectangle that I have on the board. So rectangle has two lines of symmetry. While we're on this topic, I just wanted to illustrate something else. A square. Square is a little bit different from a rectangle in that a square, if you fold it along the diagonal, that is from one corner to one corner, it matches exactly. See? Matches exactly. Because the square, all sides are the same. And if you try and fold it along the other diagonal, same story. Right? Matches exactly. They're symmetrical. So with a square, you actually have 1, 2, and the extra 2, this and this along the diagonals. So you actually have 4 for a square. Just wanted to show. And then one of these special cases, the circle. If you run any line from one side all the way to the other side through the center of the circle, you will see it will match exactly. It doesn't matter which line I choose. I just drew some of the lines here. I marked some of the lines. But the reality is, however I fold this shape, as long as the fold goes through the center, it will be a line of symmetry because one side will be exactly the same as the other side. So the number of lines of symmetry that a circle has is actually infinite. You familiar with that word, infinite? Infinite means it's a number too big to name. Don't know the number, too big. You can keep going and going and going. So that's number 40. 2 lines of symmetry. Number 41 is multiplication of a decimal by 100. These are one of those simple ones where there's a very simple shortcut to it. if it's 100, you just look at the number of zeros. There's 2 zeros there. This only works if it's 100. 1, right? 2 zeros, you take the decimal point and then you move it along 2 places to the right. That is 2 places to make the number bigger. Different if you were dividing. This is multiply, the number must get bigger. So you must move the decimal place in a direction to make the number bigger. 1, 2, and that's the new place the decimal place will be. 126 decimal point. And because the decimal point is on the end of the number, there's no real need to have the decimal point there anymore, because you know it's sitting there. Any number, if it doesn't have numbers after the decimal point, it's just sitting there, you know the decimal point is right there. You just don't show it. And that's the answer, 126. The next question tells us there's a 4-liter can. This is not the great drawing, but it's my representation of that 4-liter can. And it says that it's half full of paint. So milliliters, how many of them are still in the can? Now it's a 4-liter can. First thing you have to do is express the liter in milliliters. Now liter, milliliters. Milliliters is just 1 liter divided into 1,000 parts. So every liter has 1,000 milliliters. Every liter has 1,000 milliliters. So if I were to express that in milliliters, I would say 4 liters equals 4 times 1,000 milliliters. Which is equal to 4,000, and I'll just put the abbreviation for milliliters, which is ml. Okay, so now we have expressed the volume of the can in milliliters, and now we'll do the problem. It's only half full. Half expressed as a fraction is 1/2. So you will use that. Half multiplied by 4,000. Because we're multiplying by a fraction, we also have to show 4,000 as a fraction. All you do, put it over 1. Any number, put it over 1 and it's a fraction. Equals. Get the answer, multiply the numerators, multiply the top numbers. That's 1 times 4,000 is equal to 4,000. 2 times 1 is equal to 2. Simplify that. 4,000 divided by 2. 2,000. Because you're just splitting 4,000 into 2 parts, and that's 2,000 plus 2,000. So you have 2,000. But 2,000 what? 2,000 milliliters. And that's your answer. That's how much paint is still left in the can. All right, here you were asked to find the perimeter of a rectangle. You're given the length of all the sides. If you're given this 12 centimeters, then you know that this side is also 12 centimeters. Because to the rectangle, these 2 sides are the same length. And if you have this side 6 centimeters, then you know this side is also 6 centimeters. And the perimeter is just the measurement all around the edges, all around the external line of the shape. 12 plus 6 plus 12 plus 6. 12 plus 6 plus 12 plus 6 centimeters. 6 plus 6 there is 12, so it's actually 12 times 3. 12 3s are 36. Whichever way you want to add this. 12 plus 6 is 18, plus 12 is 30, plus 6 is 36, or 12, 24, plus this 2, which is another 12, 36. However you want to add it, it comes up to 36 centimeters. That's your answer. If they're asking for the perimeter, make sure you always include the units that you're dealing with, the correct units. Number 44 is a problem about equivalent fractions. So it's asking you, what is the fraction of squares you'd have to shade in B so that they are equivalent fractions? So basically you are shading the same proportion of B that you are of A, same type of area, or same area, proportional area. Yeah, that's probably the best way to say it. So you have 1 over 4 possible squares is the fraction that you have. Out of the 4 possible squares, 1 is shaded. So how many possible squares are there? If you look along this side, it's 4 times 5. 4 times 5 is 20. You can go the long way and count each individual square. But I'm telling you now, you have a divided space like that. You just count down this side, count over this side, and multiply the two numbers. 4 times 5 is 20. So you have 20 possible squares. 1 over 4 possible squares is shaded. What over 20 possible squares is shaded? Equivalent fractions, you find the relationship between the numerators, or the denominators, or the numerators, whichever number is given. Here it's the denominator. 4 multiplied by what is equal to 20? Multiply by 5. 4 times 5 is 20. Whatever you do to the bottom, you do to the top. 1, you have to also multiply by 5. 1 times 5 is 5. So 5 over 20 is the equivalent fraction. 5 over 20. Let's go back to the question itself, and the question asks, what fraction of rectangle B would Isha shade to make it an equivalent fraction? The answer, 5 over 20 of rectangle.
Thank you for watching.